starts quietly. Most people are asleep. Cities across the region appear calm, their lights glowing under the night sky. But far away from those cities, deep inside military command centers, radar operators begin to notice something unusual. A small signal appears on the screen, then another, then dozens more. At first, the objects seem too slow to be missiles, too small to be aircraft. But within minutes, the truth becomes clear. These are drones, and not just a few, hundreds. Across the horizon, small unmanned aircraft are moving toward their targets. Each one is relatively small, each one is relatively cheap, but together they form something far more dangerous, a swarm. Military planners call this tactic swarm warfare. Instead of relying on a few expensive missiles, attackers launch large numbers of drones at once. The goal is simple: overwhelm defenses. Because modern air defense systems were originally designed to stop a small number of incoming threats. But when hundreds, or even thousands, of drones appear in the sky at the same time, the situation becomes far more complicated. Each drone may carry explosives, each drone may attempt to strike critical infrastructure, and each drone must be tracked, identified, and intercepted. Within minutes, early warning systems across the region begin activating. Radar stations track the approaching swarm. Air defense units move into position. Command centers begin calculating interception plans. Across multiple air bases, fighter jets prepare for launch. Because once a drone swarm is detected, there's very little time to respond. Unlike ballistic missiles, drones move slowly, but that also makes them unpredictable. They can change direction, they can fly low to avoid radar, and they can arrive in waves lasting for hours. From the ground, the sky might appear quiet, but high above the cities, the battlefield is already forming. Hundreds of small aircraft move through the darkness. Some carry cameras, some carry explosives, some may even act as decoys designed to confuse radar systems. For military commanders, this is a nightmare scenario, because stopping a swarm requires coordination between multiple defense systems. Radar operators must track every object. Air defense units must choose which targets to intercept first. And fighter pilots must identify threats quickly before they reach their targets. Within minutes, the first interceptor missiles launch into the sky. Bright streaks of light rise toward the incoming drones. Explosions flash in the darkness. The battle for the sky has begun. And what happens next could determine the outcome of the entire conflict. Drone swarms are one of the most rapidly evolving technologies in modern warfare. Unlike traditional weapons, they rely on numbers rather than speed. Each drone may cost only a fraction of a missile. But when hundreds are launched together, they become extremely difficult to stop. Most attack drones use GPS navigation systems to follow pre-programmed routes. They can travel hundreds of kilometers before reaching their targets. Some fly high above the ground, others stay low to avoid detection. More advanced swarms can even communicate with each other. If one drone is destroyed, others may automatically adjust their flight paths. This creates a dynamic attack pattern that air defenses struggle to predict. Military analysts often compare drone swarms to flocks of birds. Each individual drone follows simple instructions, but together they behave like a coordinated system, and that coordination is what makes them dangerous. Traditional air defense systems must decide which threats to intercept first. But when hundreds of drones appear at once, those decisions become extremely difficult. Interceptors are limited. Radar systems have tracking limits, and defenders must constantly prioritize targets. Some drones may carry explosives designed to damage infrastructure. Others may simply act as decoys. Their purpose is to force defenders to waste interceptor missiles. And because interceptor missiles are expensive, defenders cannot afford to fire them endlessly. This is why drone swarms are often launched alongside other weapons. Cruise missiles, ballistic missiles, electronic warfare systems. Together, they create a multi-layered attack designed to overwhelm defenses. And once that happens, even a few drones reaching their targets can cause serious damage. As the drone swarm approaches, air defense systems activate across the region. Radar stations track hundreds of incoming signals. Command centers calculate interception paths. Missile batteries prepare to launch. Some systems are specifically designed to stop short-range threats. One example is the Iron Dome, which intercepts rockets and drones approaching populated areas. These systems launch interceptor missiles that destroy incoming targets in midair. But interceptor missiles are not the only defense. Advanced fighter aircraft, such as the F-35 Lightning II, may also be deployed to hunt drones in the sky. Pilots rely on powerful sensors and radar systems to detect small aircraft that might evade ground radar. Air-to-air missiles can destroy drones before they reach defended areas. Meanwhile, electronic warfare systems attempt to disrupt drone navigation. Some systems can jam GPS signals, others can take control of drones and redirect them away from their targets. This combination of missile defense, fighter aircraft, and electronic warfare creates a layered defense system. But even with all these technologies, stopping a massive swarm is incredibly difficult, because the swarm's greatest weapon is not speed, it is numbers. Once the swarm attack begins, military commanders immediately begin planning their response. Surveillance satellites analyze possible launch locations. Reconnaissance drones search for mobile launch vehicles. Signals intelligence teams intercept communications used to coordinate the attack. Within hours, potential targets are identified. Command centers must decide how to respond. A limited strike might target drone launch sites. A larger response could involve airstrikes against infrastructure supporting the attack. Fighter aircraft may be sent deep into contested airspace. Precision-guided weapons strike command centers and supply depots. The goal is not only retaliation, it is prevention, stopping future attacks before they begin. But this phase of the conflict carries serious risks, because retaliation often triggers further escalation. Each strike invites another response, and the conflict can rapidly grow beyond its original scale. Large drone attacks do not only affect the battlefield, their consequences spread quickly across the world. Air travel may be disrupted as airlines avoid dangerous airspace. Shipping routes may change if naval forces begin moving into strategic waters. Energy markets react almost instantly to instability because many critical oil and gas routes pass through regions vulnerable to conflict. Even small disruptions can affect global supply. Financial markets respond to uncertainty. Investors monitor the situation closely. Governments begin coordinating diplomatic responses. International organizations call for restraint. But during the first hours of a conflict, events often move too quickly for diplomacy to keep up, and the situation continues evolving minute by minute. By the time the first wave of drones has been intercepted or reached its targets, military commanders begin evaluating the results. How many drones were launched? How many were intercepted? Which defense systems perform best? These questions will shape the next phase of the conflict. Because drone warfare is still evolving, new technologies are constantly being developed. Artificial intelligence may allow swarms to coordinate more effectively. Autonomous navigation could allow drones to adapt in real time. And new defense systems are being designed to counter these threats. High-energy lasers, advanced radar systems, artificial intelligence-based tracking. The battle between drones and air defenses is becoming one of the most important technological competitions in modern warfare. And the night when 1,000 drones filled the sky may only be the beginning. Because future conflicts could involve even larger swarms, thousands of drones, multiple waves, attacks lasting for days. In the wars of the future, the battle for the sky may no longer be fought only by pilots and missiles. It may be fought by machines, and the side that masters this new technology may hold the advantage.